So what do we have here? We have this chip here, which is a 74LS293, and that is a 4-bit counter. The idea of a 4-bit counter is that with a simple pulse or clock, we can count from 0 to 15, or output the result in 4 wires. So the white LED here are going to represent my 4-bit of my counter. What I also added now is another chip that is here, which is a 74LS293. That is a 4 NAND. What that means, there we have 4 times 2 input and 1 output, and the function that is applied is a NOR AND. And what I have done is that I connected the 4 LEDs or 4 output of my 4-bit counter to the 4 input of my NAND on one side, and for each NAND we have 2 input, and for the other input I simply connected a 1 or a 5 volt. What's going to happen here is that as I'm going to count from 0 to 15, this will count from 15 to 0. Let's try it. For the clock, I'm using a C# program, and I'm using the Newsbuild device. So on the Newsbuild device we have this white wire, which is the clock, and I also have a green wire, which is a reset. By clocking the GPIO 0, we increment the counter, and by clocking the GPIO 1, we can reset the chip. I'm going to press F4, and here I can start debugging. But now, if I execute 1, you see we clock it once and we move from 0 to 1, and here we have the value 15 minus 1, which is 14. That's my bit 0, 1, 2, and 3. Now let's try another time. Now we should have 2, 0. So that's bit 1, bit 2, that's a 2. And here I'm going to have 15 minus 2, which is 13. So we're going to let it run. So I got it. Let it run. Okay, what do we have here? Let's start 14, 15, 14, 15. Now restart 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And as we count from 0 to 15, we go backward here. Not a big deal, but a first step to build your own 4 or 8-bit microcontroller. You will need a clock and then the counter to point to the memory address containing the instruction to execute.